Hello my friends and welcome back to another episode of Flutter Explained. I'm so happy to see you here. Today we want to learn something about sockets in Dart and want to implement that. So let's stay with me to learn everything you need to know about sockets, WebSockets, and how you can implement them in your Dart or Flutter project. And now without further ado, let's get started. And because I didn't find a sponsor for today's video, I do some advertisement for Codeberg today. Codeberg is a repository like GitHub, but allows you to be a bit more private. It's free and open source. It doesn't track you. It is hosted in the European Union. It's hosted independent by a non-profit organization in Germany. It's based on the open source GTEA criteria and it listens to community. Many popular projects are already on Codeberg, so feel free to also join it. So today is for Codeberg. My repository is also on Codeberg. I personally really like it, so feel free to check it out. And now back to the video. We already spoke about how HTTP requests are working so that you can directly call from the client to a server and receive some information. But this time it's a little bit different. We want to achieve with sockets a stable connection between client and server so that the server can notify the client when something changes. The benefit here is that it allows real-time communication, and this is sometimes really cool. Suppose you want to have a short refresher on how the HTTP requests are working. I will link you a video in the info box so that you can watch it again. Alright, great. But what is now the benefit of having a socket connection between, or better than an HTTP response request? Well, think about modern applications. We don't really want to wait till data are there. We want to be as real-time as possible. And if you think now about Firebase with the Firestore service that they provide, you will think exactly right. This is how they do it. So when they talk about real-time data, whenever something changes in their Firebase application, they created a socket, or in that case, probably a WebSocket, that automatically notifies the client about changes. That are the streams that you sometimes receive from Firebase to automatically update your data. So before we had this big benefit of WebSockets or sockets, we had to poll every time for data. So that means you would trigger a long-running build on a server, for example, and would like to receive the answer from the server. Then you would need to ask every, let's say, 200 milliseconds, hey, dear server, is the data finished that I really need? With WebSockets, we can now do something different. We can say, okay, make this long-term running task until you have finished. I keep the connection open, and as soon as the connection finished, so the server says, okay, I'm done with the file, and pushes the thing to the socket, the client will receive that file as an answer and will close the connection again. And with that, we have the round trip saved. We don't have to poll every time, like every 200 milliseconds. And when the data is there, we can directly react on that. Most chat applications that work in real time are done with WebSocket technology. Just to make sure that we are on the same page, if I talk about sockets, I also include WebSockets, even though that is not completely correct. While sockets are living on a lower level and are more directly for different clients, WebSockets usually work on the client, like on a browser, for example, can work with WebSockets. It has a lot of HTTP sugar around it to make the usage in browser and front-end applications a bit easier. I talk today about sockets. My first example will be pure sockets. With that, we will work with two Dart terminal applications that will speak with our server. And afterwards, I will create a Flutter application that will talk with WebSockets with our server. All right. Just to make sure there is a difference, and feel free to read down in the comments all the documentations about it to make sure that you really understand what you want to use in your case. All right, now that we are on the same page, what WebSockets and sockets are and how they are working, how they can benefit us, let's see how we can implement that in real code. As always, you will find the repository down in the video description so you can follow along to the tutorial, or what you can also do is enhance that tutorial. And if you do so, please feel free to send me your solutions that you have done there. I would be very interested what you do with WebSockets. And if you are still here, don't forget to like this video and subscribe to our channel. It will be beneficial for you. In the next couple of days, there will be more and more videos up there. It's sockets. Now we have ESADB that we want to talk about. And I have a lot of more topics that I want to show you. So feel free to follow me. And if you want to take part on votings, feel free to also join me on Twitter. Great. Now back to the video. All right, but before we begin, let me quickly give you a short introduction what we want to do today. So we have the terminal where you can see the top one will be our server, the second one will be our client, and the third one will be another client. So let's start up here as server. As you can see, the server is running on 003,000. And if we start up a client, it will ask me for a username, which will be Max in this case. And you can see the connection has been done in the server side. And the same thing we do with our second client, but this time we are Mahtab. And as you can see, Mahtab has joined the party, is visible in the first client. And here we see that the connection happened on the server side. All right, so now let's get into it. All right, as you can see on the left side, we use for this time the repository of Codeberg, which is nearly the same as GitHub, but it allows us also to be a bit more transparent with our code. So here you find the tutorial, and here socket tutorial part 1. If you want to follow this tutorial here along, you have the possibility to do it here. And if you want just the solution and go with it, the solution part is here visible. And if you see the main tag, there I did some experiments and already created some advanced stuff. So if you are interested how it goes further with the socket part, you can take a look into the main branch. All right, so now I explained the tutorial. You find it down in the video description below. And I start now with the solution. All right, so let's start with the tutorial. We will first define the whole server side. So we will create an IP address. We initialize a server socket so that we can receive socket connections. Then we want to listen to incoming connections, inform that the server has a client that is connected to him. Then we wanted to listen so that we can write information to the client whenever it's important. We handle error cases, so if something went wrong. We handle if the client is leaving, so that the server is also knowing that. And at the end, we want to create a list of different clients so that we can send messages to all of them or broadcast them, to be honest. Good. So that's the general idea for the server side. All right, now let's switch to the client side. For the client, it's important to do exactly the opposite thing. So we want to create a socket that can connect to the server so that it can listen and inform the users about things that happens there. So we listen to notifications. We print that you are connected, well, not so important, but then we want to handle incoming data. So when the server sends us data, we want to do something. If we get errors from the server, we want to handle them. If we have a server that's left our channel, then we want to also disconnect from that socket so the client don't have to be active then anymore. After that, we want to ask the user for his name in the terminal. And if he enters the name, he should receive the information you are logged in. Or when you have a second part that is connecting, like a second client, then we want that the username of that client is visible somehow, and all the clients that have connected to the server get informed that there is a new player joined. All right, now let's jump into it. We will first define our server fully, and after that go to the client. All right, in order to get an IP address in Dart, we can directly say internet address, any IPv4. That will give us a free IP address so that the server can start up. Usually this is 0000, but it could be that it's different. So for example, if you deploy it to Heroku, we did that already in a video, you find it up in the info box, then it will take the port that is free for it. So that's a great way if you don't really know which IP address is available for your server. After that, we have to create a socket, a server socket, where we create that. And as you can see, we pass in the IP address and we just say 3000 as a port. Again, in Heroku, there will be a system variable that you have to set so that you have the possibility to use a generic port that is created for you. But also that is covered in the Heroku video, so feel free to just watch that again if you have questions there or read the blog article. Then we want to inform our users that we have a server running on that IP address with that port. Okay, but now it's getting interesting. Now we want to first time listen if someone is connecting to that server, and if so, then we want to handle this connection. So what we do is server.listen, we receive a socket as an event, I just called it event here, and then we implement now a function called handle connection. Okay, so now that we are that far, let's remove some to-dos. So get free IP address, we have done that. Initialize the server socket, we did that here in line 8. Listen for incoming connections. I think that's that part, so we can also remove that. And now we have to handle these connections. That means whenever a client connects to our server, we want to do something. And we have now, I put that outside of the main function. That's very important. So handle connection. And here we receive, as we write above, we receive a socket, which is our client. So, and this method does not return anything. All right, so we get our client socket. What does that mean? We want as a server now to listen for the client if he sends us messages or informations or data that we can work with. All right, so let's listen to the client, which gets us a socket. And if we take a look into the description, so we can also jump in, but to make it easier, we just use now the IntelliJ functions. We can see we get 3 methods that we can provide. The first one is onData, which means we receive data from the client. So what do we want to do with it? Do we want to convert it? As you can see, it's a uint8 list, which are just bytes. And these bytes needs to be converted into messages or objects. So we have to make the parsing here. On the other side, we have an onError function, which means whenever an error happens from the client side, we can collect that here and do something on it. We have an onDone method. That means whenever the client closes its connection to us, what do we want as a server to do then? And last but not least, cancel on error, which means more or less whenever there happened an error, do we want to close the connection to the client? Okay, so now let's implement that quickly. So we have 3 methods that we have to pass in. The first one is uint8 list that we receive. That's our data. So that should be green. The second one is our onError. So we can write onError. It's voila, and we receive an error, which we do with print red error. So we just, if we receive an error, we just print it out in that case. And then we say client.close. So if there is an error, we close the client. We could also do that with the Boolean flag, you remember, but we don't want to do it in our case here. So, and last but not least, we have onDone, which is a pure method where we say print warning. And here inside, we just say server to identify who is writing something in the inside of the terminal later. Oh, this is the server side. The client left, so it will be yellow. And last but not least, we say client.close. That's just closing the socket on the server side. Okay, and with that, we have already made our boilerplate. So we have now the chance to listen if the client is sending us data. We will do that in a second. Then we have handled the error case and the onDone method. And here we need, as always, a semicolon. Great. So we have, again, green code. So if we take a look back on our different to-dos, we can remove some. We can inform the server. We did that. We listen on the right information from the client. That's this part here. So we can remove that. Handle the error cases. That's this part. We can remove that. And 7 is onDone. So we can also remove that. Now we want to add a list of clients to track all sockets so that we can broadcast informations. Okay, we do that above the handle connection. So create a list of socket clients. And inside of here, we have just an empty list. And whenever we connect now and we listen to the server, we receive a message. So string from char codes. Whoop, that's char codes data. So here we receive now the message and serialize it into a string. So, and if we do that, we can say clients.add the client itself. So we save us the socket for later. And last but not least, we want to say client.write. So we send an information now from the server to the client. Here, good. And this will be server. You are logged in as message. Because as we know, the message will be later the username, right? Okay. And one more thing we have to do, because we want to broadcast information to all the clients that exists. We do that in that part where we say, okay, for loop in clients. For every client in this clients list, we want to write now an information from the server. Hey, dear message has joined the party. So whenever a new player joins the game, the message will be the name of the player, and then we send it to the client so that every client knows now, hey, there is a new player. Good. So that's it with our server. Now that should run already, and we can remove the last to do. And if I go now to the terminal, we can say dart.bin/server.dart. If we execute that, we see servers running on this number, and we will need that in a second. All right, in our main function of the client, we want to first connect to the server. As we know, the server is running on the localhost IP and 3000. Now we want to connect directly to that server, and it's very important that we know where that server is so that we can do that. So we pass in the socket, we import that from Dart.io, connect, and here inside we directly take the IP address and the port. So, and with that, now our client was able to connect to that server. So let's inform our users to it. So we have here a short message connected to the remote address and the port. So now in the next step, we want to say socket.listen. So we do actually the same thing as on the server, if you remember, because the socket is nothing else than the port. So we know now the server is answering us with something. And if we know that, then we receive onData again with T event. Then we have the function onError and onDone. And as you remember, maybe this onData was for us an uint8 list. So if this happens and we know that, we can directly implement it again. uint8 list is our data that we receive from the server. Then we have again onError, which we remember, right? So it's a method with error where we print in red the message client error. So we pass it just outside. And if this happens, we say socket.destroy. That's the only difference to the server in that case. The socket needs to be destroyed. The client gets closed. All right, and after the onError, we have also onDone. That means whenever the server is disconnecting, we also want to inform our clients and users. So we print in, I would say in a warning, or better in an error, because as you remember, that's pretty harsh if the server is dying. So client says server left. Okay, and last but not least, socket.destroy. Good. And with that, we cleaned everything up. All right. In order to wait for a response, we just do the following. We go here inside and do the same thing as on the server. We have to get from char codes the data. So final server response is a string dot from char codes, and we pass in the data. Good. From here, we print in green because it's a success if we get a message from the server, client server response. No, that's not completely true. We have to make that this way. Right. Good. So whenever the server tells us something, we should run up. All right. So now we have the possibility to first test something because our client sends some infos. It connects to the server. The server should send at least a message, hey, there someone has connected. So that is maybe the first time that we can test something. So I prepared an iterm2 terminal where we have the possibility to create 3 horizontal terminals. And the first one here up here should be the server. That one is a client, and that one is our second client, so that we can test the broadcast functionality. So let's go up to the server and start that up. Bin server.dart. We receive our address. So let's go for the next one directly and create our first client. And voila, we receive connected to that IP address 3000. Interesting enough, our server does not respond well. We have to check. The reason why we don't get any information from the server that the client has connected, there was something missing, is because in the handled connection, I forgot to add a message like, hey, there has someone connected. So let's try it again. I add that, go to the iTerm. We run our server first. Now let's go and create a client. And now we can see that there is a connection from localhost on the port 53254. And that's interesting because every client will receive a different port. Okay, but now let's ask the client to enter a username so that we can see if the broadcast is also working. All right, back to our to-dos. We can remove the client 2, 3, 4, 5, 6, because all that is done with that listen function up here. But we stay now in the main function, and now we want to ask our users for a username. So let's do that. First, we need a string, which could be null username. And then we say do, and print something like, please enter a username. And then we do that so long, or we wait so long until the username is not null anymore, or username is empty. So I hope that makes sense. That just means do it once and afterwards always whenever it is null or is empty. So we make sure that afterwards the user has actually a username. And if we have a username, we say socket.write and pass in the username as a string. And that's it. All right, so let's test that in real life. Let's restart our server quickly. I am not even sure if that is necessary, but I want to do it just in case. Oh, something went wrong. Let's have a look what went wrong. Why do we send all the time? Of course, because it stays empty and we don't wait for something. So what we need to do is say actually STIN read line in sync. So that means we want to wait until the user entered something. Start that again. And up here we can see the connection, we can see the client left, and now we have a new client. And let's say, hey, Max wants to join. Okay, so now you are logged in as Max. Let's see if we can get the second one running up. So Dart bin client.dart. And let's say this one is now Mahtab. And if we check the server in the meanwhile, we can see we have now two connections, one time from 53289 and one for 53291. This is always the port that changes for each client that connects. So let's see what Mahtab does. Woo, you are logged in as a Mahtab. And as you can see, the client server sends us Mahtab joined the party. So with that, we have the option to show who is connected. We could create more and more clients. So if I want to, I could even create multiple ones, and 5, 6, 7, you can test that, and everyone can join the party. And that's pretty cool because with that, we could do funky things like games or anything like that. So I'm really interested how we can do that. So that's the first steps to do something really, really cool with Dart. All right, that should give you already a very good idea on how sockets work and what you can everything achieve with it. No more polling, no more waiting for data. And the best thing is you can create games, for example, like Pong over the internet. You can do so many great things. And I really want to know what you plan to do with sockets. If you enjoyed that topic as much as I did, please let me know by hitting the like button. It's really important for me this time because it shows me that you are interested in sockets and you want to know more about it. And I would also take that to another step that we implemented in Flutter, and maybe that will work, for example, with Socket.io. Please let me know if you like that, and then feel free to share that video. And with that, thanks for watching. Until the next time, I'm really happy to be back, and we see us in the next week. Bye, everyone.